Okay, the recording is on. So let me log in my system here. So I've been working in this system here, right? So what will happen is sometimes you need to set the age of the password not to expire. Okay, so how do you check the password information here for a particular user? The command is chage. Okay, chage hyphen L as in Larry terminator. Okay, so I have to be root. So I'm going to become root. chage hyphen L terminator. So what will happen here is you're getting information here. Last password changed. This is when the password was changed. Probably that is when the password was created. Okay, and it says password never expires. Password is inactive. And account expires never. Okay, and the maximum number of days between. Okay, so the reason we are getting this is the definitions are not defined. So if I go into vi/etc/login def, login.def stands for definitions. Okay, and in here so password maximum days is 60 and password 60057. Okay, this looks good.
Is warn age 7?
What about it?
What is warn age 7 with the numbers you just went through?
Okay, where at?
More. Yeah, right there. Like password minimum length 5 and warn age 7.
Yeah, so warning, it will warn you 7 days before the password is expiring.
Expiring. Oh, okay.
So the maximum days is 60, right? Every 60 days you're supposed to change the password, but it will warn you 7 days before changing
So
the password.
is that in the system we cannot change that 60 days?
You can.
Okay, okay.
So give me 1 second. So give me 1 second here. Let me add a user and see what his password is coming up to. I'm gonna do password terminator. Why is it not working? Actually, it's not working right now. So I need to go in here and this settings looks good to me. Minimum number of days a password may be used, 60. Okay. So what I'm gonna do is I'm gonna quit. I'm gonna SU as a terminator. Okay, and I'm gonna clear this, and I'm gonna set terminator password as terminator. Just type password there, okay? And current password, Red Hat. New password, Red Hat 01. Okay, here's the thing here for the root user. You could literally put any password in there. There is no restrictions, okay? But for the regular user, if they are setting a password, it has to be a complex password. Okay, so what it should happen here is if we do, let me set a complex password here and see what happens here. So bad password too similar to the old one. Okay, so it's kind of taking this one. Okay. Now if I do CHH-L terminator. Okay, this is not right. So if things are not working, what do? You're gonna put in Google. Okay, so okay, let me actually change it and see what happens here. Okay, CHH-L terminator. It's just not working.
we only see H terminator.
No, you could see any user in there, definitely. If you do ch age hyphen I and then terminator, you should do this here in
Is it hyphen I or hyphen L?
hyphen L.
Okay.
This is not what I want. Well, anyway, so this looks similar in VMware also, but what you're seeing here is if you go into storage, literally there are hard drives here. So under controller, SATA controller, we have hard drive 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hard drives here. Okay, this is how it will be in there, and if you need to add, you have to turn the system off and add it here. So that part is not covered in this course here, so I mean, just don't worry about that. If you need to add a hard drive, you just have to go in here and then you will get some little help to add a hard drive, or somebody in your team, they will do that, because there are some dedicated people who are just doing the VMware part. Okay.
Professor, I
Yeah.
have a
Yeah.
question. So 8 is it a different number for
No,
hard
no,
drive?
no.
Okay.
Why are you thinking that way?
Mhm. Okay, because here I have 7 here. That's why.
You have what?
7 drive hard drive.
No, you. Which one you using? The one you from me, the pre-configured VM.
Yes.
It should be the same exact VM I gave you. Look closely. It should be 8.
Okay.
I mean, if it's not 8, just don't worry about it. Okay, you could add whatever you want in there.
Okay, sir. Thank you.
Okay, so now, now that we have this here, so you just got a visual here. We have 8 hard drives here, right? So what is going to happen to these hard drives here? How do we start using this in Linux operating system? So when you do lsblk, what is this thing coming up here? I have no idea. Can I close this? Okay. Do I need to annotate, or is this good enough here? You could see visually what you are looking at it.
Hey, Mr. Zafar, can you do a quick annotation, just like a skim through of it?
Yeah. All right, give me one
Thank
second.
you.
Yeah, I need to get an iPad. Good boy. Close the door.
Your class done?
Yeah, no, I'm in the class right now.
Break?
No, not yet. Close the door. Okay, so let me do this. Okay, so this is our, so this is /dev/SDA. Okay, the operating system. Okay, here's the funny thing. Operating system is gonna handle the hard drive or anything as a file. Okay, Linux OL will manage devices as a file. Okay, so that is very important here. So SDA is actually a file. It's sitting in the /dev folder. Okay, and so SDA is nothing but /dev/SDA, and SDB is nothing but dev slash, it's a file name, SDB. Okay, and then you have to just look across. The size is 4 gigabytes. Same thing. SDD, you just have to worry about the size. Okay, SDH, what is the size? You just look around and you see, oh, this is the size here. Okay, and then within SDA we have SDA1 and SDA2. It has partition 1 SDA and partition 2. Partition 1 is being used by boot, and then partition 2 has another 2 partition in here, logical volumes. In there, one volume is slash and another volume is swap memory. We'll talk about that swap memory later on. Okay, but at this moment what we are worried about is the hard drives here. So hard drives, even hard drives are being handled as? How are the hard drives is being managed as? They are being managed as nothing more than a file. So I think I made a statement in Linux, everything is file. A folder is a file is a file also. Okay, all right, good. So let me save this. So you have the command you use is lsblk, and this is the common command here. I use this every day. Every day I'm using this command. It stands for lsblk, stands for list block. In generic terms, it's considered as a block. A hard drive is considered as a block. So when you do the lsblk, for example, if you had a USB over here, it would show up as in lsblk, USB 01 or something, whatever. Okay, so now what we're gonna do is we'll manage the disk here. So first we identified the disk, what it is, and now what we need to do is we need to start using the disk here. So for that we have to format it. Okay, so what will happen here is logical so all these are disk. This is a disk and disk. This is a disk. This is a disk. And those are the size. You look across and you will see the size of the disk. So now what we're gonna do is we're gonna do the Fdisk. Okay, so what is Fdisk? There are some commands we're gonna use now. So there are a few things you should remember. One is Fdisk. First one is Fdisk. Okay, so this is called fixed disk editor. Okay, and gdisk is same as Fdisk, but it's using the GPT format. Okay, GPT format is mostly used in Windows environment, so we're not worried about that. And the last one we're going to use is LVM. You all guys need to be master of LVM to secure the Linux job. Okay, I'm giving you everything you really need, and you have to just day in and day out practice this, what is going to be happening this on this topic. You must know what is LVM very good. So what we have is we have 3 common ways to manage the disk. Okay, so we will be using the Fdisk, and you know what, let me just get rid of Gdisk. It's just giving two common ways to manage the disk, Fdisk and LVM. So we will be using both Fdisk and LVM to manage the disk here. Okay, so let's concentrate on Fdisk. Okay, so let me find the more information about Fdisk. Okay, so dialogue driven. Okay, I'm not worried about that. So let's run some commands here. Okay, so everybody clear the screen and do lsblk. Everybody please log in as root and be in your first server. Okay, I'm logged in as root and I'm in my first server, and then 0 in on /dev/sdb. Okay, so here's the command. Type fdisk, fdisk, and then /dev/sdb. Fdisk space /dev/sdb. And then hit enter. Now you should see this screen there. Let me capture this while I'm doing. And the very first, you enter the Fdisk mode, and the very first thing is asking you type M for help. Okay, so it's actually M for menu here. So go ahead and type M. Before that, it says welcome to Fdisk utility. It's giving you the version. Changes will remain in the memory only until, okay, so it's don't worry about that. Just type M as in Mary and hit enter. Okay, what you have here is you have a menu here. So just think Fdisk, just think /sdb as a open room, open space. Okay, now what we're doing is we're using Fdisk to make a rooms inside an open space. So what we're going to do is we're going to N for add a new partition. So put N as in Nancy and hit enter. And it will tell you the primary is already selected. So hit enter again. What partition you want. The maximum partition it has is 4. And then afterwards there are some logical partitions. We're not worried about it. We're only worried about one partition here. I'll hit enter. And it's talking about the sectors and all that. I mean, I could talk about that, but it's not necessary for this class. So hit enter again. And then hit enter. That means we are taking everything. The disk size, the entire disk size. Okay. So what happened here is we created a partition here. And if you want to see if the partition has been created, push P as in puppy and hit enter. That means print partition information. So here we did N as in new partition, and we did N enter, and then over here so we are doing enter to accept default. Okay, go ahead and do that. I mean, you guys already have done that, but I'm just getting this for documentation. And partition ID, hit enter for default, which is 1. And here also hit enter for default. Okay, and then same thing here, enter for default. And then you got the message of partition 1 type Linux, and of the size 4 GB byte is set. Okay, so this is what the output is. So now on your screen, one of the menu is print partition table. So whatever we created, we want to see if it has been created or not. So type P and hit enter. So now you see under here SDB1, okay, one partition is created using the entire disk size. Okay, so out of the open space we have, one room has been created. Okay, so now we have 83 here, right? So what we have here is system ID is set to 83. We need to change the system ID. Okay, and if you look at the menu here, the information we are interested in changing is the partition type. ID is referring to 83, right? But we need to change the partition type, which is list known partition types. We're gonna first list it, and then we're gonna use for L to list the partition types, and then we're gonna use T to change the partition ID. Okay, so everybody go ahead and push L and hit enter. Okay, you have all these formats here. This is just informational here. Okay, so we type L and hit enter. Okay, this is horrible. This is a horrible picture here, so I may have to take a screenshot. Okay, so the one we are interested is in AE, Linux LVM. Okay, right now it's set to 83, right, which is Linux right here. We are not worried about that. We need to change it to Linux LVM. So right now this is set to This is set to 83, which we don't want. What we want it is, we want it to set to 8E. Okay, this is important here because, okay, so what is all this here file system? You have like empty, and then we have all this here, right? FAT32, NTFS, Linux, and all this. Okay, just think this as of a, so in your house you have a flooring, right? So the what kind of flooring format in your house? What kind of flooring format anybody could have? Anybody have any idea? Mirza?
Can you repeat the question one more time?
So if you have a house, right,
Yes.
and you have a flooring choice, what are your choices?
Yes. Hardwood floor or carpet?
Yeah, very good. Just think all these as these are the flooring options, okay?
Okay.
These are the flooring options for your hard drive. So these are the options you have to choose from. But the only thing I always deal with is 8E, Linux volume, Linux LVM, logical volume. This is the only thing I worried about. Okay, so simple enough here. I mean, I don't want to confuse. There are a lot of things in there you could study about, but those things are not necessary. All these formats, all this showing from the beginning of our time for computers, so we're not worried about it now. It's not being used. It's a horrible picture there. What I need to do is I need to take a screenshot of a screenshot. Okay, so let's go ahead and change it. So L, it gave us the list of options here. And then T is actually change the ID. So let's go ahead and put T as in Tammy and hit enter. And then it's asking for the hex code. What is the hex code? 8 as in number 8 and E as in England. And hit enter. Okay. So now it says the partition ID has been changed to Linux LVM. This is exactly what we needed. In the next round, we will just breeze through this, okay? You don't have to worry about all this. And then go ahead and do P as in Papa to print the information and verify that 8E is actually what is set to. Okay, so now everything looks good here. Now if you look at the menu, we're going to use W to write and exit. That means it will save the changes. And it will give you this output here. So this is beautiful. We have accomplished what we are looking to do. So when you do W and hit enter, it is working. And so this is successful here. When you get this information out, the LVM is successful. Now you're back to your old command line. So how do you see if the partition is there without going in the fdisk menu? Just type fdisk hyphen L as in Larry /dev/sdb and hit enter. It will print you it will give you the output information. It's like catting. Without going inside the file, what do? You cat, right? That's what this is. All right, let's do this real quick with me. Let's do this blindly, very fast. We're gonna do it to the all other drives here, okay? Everybody with me, right? It's so dead quiet. I hope everybody is up with me. And also, if you do lsblk, now you see have a partition in there. SDB is there, but it has we made a room inside it, a blank room. Okay. We use the open space SDB and created a room inside it.
Question, Mr. Zafar.
Yeah.
When we created the partition, right now for both the disk space and the partition space is both 4G. So is that because we didn't change it, or it automatically allocates?
The very, very good question. Why? Because we just breezed through and we accepted to use the entire disk space here.
But both of them, okay, all right, got it.
So over here, if you do the math here, default, these are the sectors here, right? So this is,
Yep.
so this amounts to 4 gigabytes. So let's do the math here. 83,800 and whatever that number is, 88607.
It's 8,388,607. Okay.
So this is divided by
4. Since it's 4
1024.
gigabytes.
This is divided by 2048, I think. 8388607
Okay, yeah, it is 204.
divided by 1024. So 8,000 megabytes. 8,000 megabytes is what? 8 gigabyte.
Yep.
And divided by 1,000. I'm sorry, not 8. Okay, can I bring that number back? 8388607. I hate why, it should have at least given a better output, right? I mean, this is so annoying. It should give you in megabytes and gigabytes. It's giving you in bytes.
We can't, when we're running the command, I'm pretty sure we can't do the -h to make it human readable, right? Just to make it easy for us. I mean, when we run lsblk, it does give it in a human readable format, so that's fine.
Yeah. But here, unfortunately, it does give you that way in here. So the best thing you could do is like a calculator, byte calculator, and so you put in the number, which is what is the number we have here? This number here, right? 83.
Yep.
Oh, this one is bytes. Okay, yeah, this is the correct number, and this is the sectors. So, I mean, there is I don't want to go in that area, but so we are connecting bytes to, let's do gigabytes. GB bytes. No, not GB bytes. Gigabytes. GB bytes. Okay. There you go. 429 is exactly, it's coming up to 4 GB bytes. See? That's what we have, 4 GB bytes. So for what is happening here is it's giving you the large, very large number, which is starting in bytes. So the building block of this numbers, megabytes, gigabytes, is bytes. 1 byte is 8 bits. Oh God, I don't want to go in there, but let's see. uh, okay. Okay, so 1 byte is 1, 2, 3, 4, 5, 6, 7, 8. No, this is just giving you uh it's not giving you the number value in here. This is good information here. Oh, it's telling you all the information we ever created. I'm not worried about that now. So okay, look at this. This is what I was looking for. So 8 bits is 1 byte, and 1024 bytes is 1 kilobyte. Why is this coming up to 1024 is actually you have to go back to basic math, binary. So what you have here is 10 to the power of, you have okay, give me 1 second here. There is no way out of this, so I have to do this. $192. Booting. So what you have actually is So the smallest one we have is a bit. Okay, so 1 bit, 1 bit equals 2 to the power of 0. 2 multiplied 0 is going to be 1. Okay, and then this is bit, 1 bit, because we are into the binary. Everybody knows binary, right? 1 and 0 is binary. Okay, now the next level up is 2 to the power of 1 equals 2 to the power of 1 is 2. Okay, and this is 4 bits. I'm sorry, this is 2 bits. And then the next one is 2 to the power of 2 to the power of 2 is what? Is equal to 4. This is 4 bit. Also, this is called nimble. Now, what is next up? 2 to the power of 3. So 2 times 2 times 2 times 2 multiplied 3 times to itself is what? 8. Okay, this is 8 bit. And this is called byte. Now nimble has 2 nimble is 1 byte. So 8, and this has become byte. So, and then again, what is the 2 to the power of 4? 2 raised 4 times is what? 2 times 2 times 2 times 2 4 times is
16.
16. Yeah. So now this is 2 byte. Okay. So now this is 2 bytes. So this is where all this gonna go up all the way 1 byte. This is 1 byte actually. 8 bits equal to 1 byte, and this is 2 byte. Okay, so this really gets a lot interesting here. So now let me save this. Okay, so now here's where the math starts here. So everything is based on bytes now. Okay, so 1024 So what is happening here is, if you want to go, this will go all the way up to 1024. So this is the 1000 times, right? So 2 to the power of, let's see here, if I do 2 to the power of, that is square actually. If I may go into scientific, and 2 to the power of, I think it's 8. No. Okay, so clear this. 2 to the power of 10. Okay, yeah. So the benchmark is 10th, right? 100 million. What is 1000 million is billion, right? So this is the 10th. It's going up to 10th here. So 2 to the power of 10 is 1024. It becomes 1 kilobytes. Then 2 to the power of 20 is 1 megabyte here. 2 to the power of, is it 20? Let's take a look. 2048 divided by 1024. Yeah. So it's going 2 to the power of 20 and 2 to the power of 30, and it's keep doubling itself here. So what is happening here is it started off with byte. Bits is there too, but bits has been kind of forgotten, and it's based on bytes here. So if you go bytes, 2 to the power of, all this is based on binary, 2 to the power of 2. What is binary? 1 and 0, that's it. That's why number 2 is coming in all the time here. So the machine language, it understands nothing but a binary, right? This is not new actually. It's going, I mean, the concept of computing is not new. I mean, it's just the technology has propelled it forward, because people back in the days, they have knowledge about zeros and ones and all that, but they just couldn't represent it. And binary, by the way, binary is actually based on, so the numeric numbers here, right? So when you look at the numbers here, what is the numeric numbers? If you look at the numbers here, right? If you type in Google numbers here, numbers, oh God. Okay, if you type numeric numbers, and when you go into images here, so the numeric number is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so, but actually the numbers you're looking at these are Arabic numbers here. So instead of typing numeric numbers, if you type Arabic numbers, you will get the same result. Okay, so the numbers we are using today, it comes from the Arabic numbers here, Arabic numerals. So the numbers we are using is coming from the Arabic numbers here. So, and also right here, These are Arabic numbers here, 1, 2, 3, 4, the ones we are reading. And also the number binary representation, zeros and ones, is going from right to left. Why? Because Arabic language goes from right to left. So in actuality, the numbers you're looking at, it's going from right to left here. But there is a lot of deep things you could research on your own. But here's the general point is, don't worry about that too much. Just worry about gigabytes and megabytes. Unfortunately, these things give you in like large number here, which is confusing. But as long as you remember, oh, this is megabytes, gigabytes, then you should be fine. And next thing is going to be up is terabytes. The most thing you're going to be ever deal with, the larger number is so far is going to be the terabyte, and the smallest number would be megabytes. You won't be dealing with kilobytes and all that. It's nonsense. Well, here you got like megabyte here right in front of me. But don't worry about it too much. Let's take a break for a good 20 minutes. We'll come back and then we'll go through all the other drives here real fast. Okay, so the break starts now for 20 minutes. All right, so let's continue on. So let's go ahead and do it for SDC real fast. Everybody with me, right? So I'm going to do fdisk /dev/SDC. Okay, and hit enter. Okay, and then here push N as in Nancy and hit enter. Enter, enter, enter. Keep doing enter. Okay, and now what we need to do is we need to change the code. So do T and hit enter and type 8E. Enter. W enter. Okay, so I did real fast here. And if you do fdisk -L/dev/SDC, and you should see the partition has been created and it's set to ID 8E. And one other way to confirm this is lsblk. And you see SDC has been created, a partition. Any questions? All right, no questions means let's continue to SDD and SDE. Go ahead and continue to all the way to SDH. Okay? I'm going to bring the line back up, SDC and SDD. Okay, now I'm going to do fdisk. And then I'm going to do N, enter, 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 enter. T, enter. 8E, enter. Write and exit. There you go. LSBLK. SDD is ready. So what we're doing here is we are readying the hard disk drive. SDD and SDE now. N, enter, 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 enter. Okay, T, change the code. 8E, enter. Write and exit. LSBLK. And you see SDE is ready. Okay, can one of you confirm you are on with me?
Hey, Mr. Zafar, yeah, I'm following you, but can you go a little bit slower? Just a little bit.
Okay, where are you right now?
I'm doing the SDE right now.
Okay, go ahead, and where are you in SDE?
I just did the fdisk/dev/SDE, so now I'm gonna do the T and create
No,
and
do
type
N.
80.
Did you do N already?
No, actually I gotta do N first, sorry. Yes,
Yeah,
I'm gonna do N.
And
then
hit enter and then hit enter multiple times.
yes. Okay, and then T. and then H E
enter, W enter.
and W. Okay.
Then do LSBLK and you should see the partition in there.
Okay, and you are at which disk right now? You're at SDE as well, right?
Yeah.
Okay.
Continue on all the way to SDH.
SDH. Okay. All right.
Okay, anybody having any issue?
What is the next partition, Professor?
Say that again.
I said, what is the next partition?
I still didn't get it. What?
I said, what is the next partition? Because I already done the SDH.
Okay, good. Just wait there.
Okay.
I'm waiting for everybody else to complete. Once everybody else is ready, then we'll move forward.
Okay.
So I'm gonna finish mine. Okay, so all these things looks like this now after completing. Okay, everyone should have at least one partition in it. So now what I'm going to do is I'm going to copy and put it in there. Okay, so once we have done this, now what we're gonna do is you could also do, like, if you do fdisk for multiple disk, fdisk -l, I think you could do dev/sdb and then dev/sdc, and it will give you the partition, both partition. I mean, just the thing you want to see, the output for both of them. But now let's do lsblk. Now what we're gonna do is we're gonna use 3 drives here, 1, 2, and 3. 3 drives. So how we have, like, all these 3 drives are different drives, right? Different sizes. But what we're gonna do is we're gonna combine all 3 and make it a one big chunk of hard drive. Dev sdb, dev sdc, and dev sdd as one single drive, also known as volume group. Okay, so how are we gonna combine all this here? First, we need to use the pvcreate command. It's a new command you're learning. What pvcreate does is it will create the volume group for you. I'm sorry, the physical volume. It will prepare it to be used with the logical volume. So how are we gonna do that? So I'm gonna do pv create /dev/sdb, dev/sdc, and dev/sdd. So what is happening here is we are combining 3 drives. So pvcreate, what it does is, this is the command. Okay, and let me get rid of the color, different color here. So this is the command. And it stands for PV, means physical volume create. And we are using disk 2, 3. So what we are using is we are using the disk 1 is 4 GB. Okay, this is 4. The next one is what? 8. SDC is 8G, right? And then SDE, SDB, SDC is 8, and SDD is how much?
12.
16.
16.
16G.
16.
Yep.
16G. Okay, I did a small mistake here, which I regret. So this is gonna be 1. SDB1, SDBC, SDBC 1, and all ones. Not just that. So So this is
Quick question, Mr. Zafar.
yes.
If we're combining the three hard drives, the three SDB, SDC, SDD, then why do we have to do the partitions as the PV create? Don't we just use the main SDB?
Yeah,
Or
that's a
when we
very,
create
very, very good question. The primary reason is we are setting that partition ID to be 8E so that the operating system from the core
It's gonna be 80.
understands that these are the logical volumes. Okay,
Okay.
you could definitely jump to PV create, but later on it will start to lose the disk size. The disk size will not be the same.
Okay.
So it's a very, very good idea to do that, and your question is very good. I am really happy that that question came into your mind.
Okay.
So this is PV create is physical volume create. Okay, this is the physical volume create, and these are the physical volumes 1, 2, and 3. This is going to be 4G, and this is okay. Hold on, 4G and 8G and 16G. Okay, when we combine all these three together, it will be how much is going to be 16 plus 12 is what? 28 GB, right? Yeah, right? 28 GB? 28 GB. So if I hit enter, and you get a message that says physical volume SD1, all these are created successfully. And there is a command called PVS, physical volume show, and it shows you that these are the physical volumes here, and it attaches you the LVM partition information in there. PVS stands for physical volume show. Okay, in here, if you notice, this one is actually using LVM2. So the other part, SD1, SDA1 is not showing here because that's not logical volume, that's something else. But we are using this logical volume is going to show you, the PVS command is going to show you. And then PV create, physical volume create. So it creates a physical volume for us so that it becomes a part of a logical volume. Okay, now what we're gonna do is all three disks are there, but we need to put everything together and give it a single name. Okay, that is when the volume group is going to come in right now. So if you do VGS is volume group show. It's showing only one volume group here, but we are not worried about that. That's done by the operating system directly. So let's go ahead and concentrate on creating a volume group. So the command is, I'm going to show PVS just to have in our view here. So the command is vg create. Okay. And what is this going to do here is it's going to create a volume group. And over here, we have to give the volume group name. I'm going to give the name ZMPT01. Okay. And which partitions you want to make it a part of a ZMPT01. I'm going to say dev dev/sdb1 space dev/sdc1/dev/sdd1. Okay, so let me screen capture the first one I had. So this is the command. Volume group create. And then the name of the volume group. And then the partitions. You could add like 4 or 5 at the same time too. We're just dealing with 3. Okay. You guys, this is very important. You guys have to practice this a lot. Okay, so I'm gonna get out of this and then I'm gonna refresh this. Okay, and hit enter. It will say volume group successfully created. I do VGS. Now you see here, you see volume group and how it will tell you how many physical volumes it has in it. 3. Why is it saying 3? Because this is 1, this is 2, this is 3. 1, 2, 3. So when you run this command and when you look at this, it will say, oh, this volume group has 3 physical drives and there is no other partitions in there. Now all this has become one single partition from in here we could carve as many partitions as we want. Okay, so give me a moment here. I'm gonna wrap this up a little bit right now in another 10 minutes.
Mr. Zafar, while you screenshot this and put it in the notes, can I ask you a quick question?
Yes.
So when you just ran the VG create command for the volume group, couldn't we have done just VG create after we had created the partitions, or you always have to create the physical volume first?
You have to create a physical volume. You have to do
It has
PV
to be
create.
physically created first?
Yeah, because it will assign. It's when we
The
do
full-
PVS, it's not showing up here LVM here. PVS is a part of a LV logical volume command.
Okay. So if we hadn't done PVS, I mean the PV create, and if somebody just ran VG create, it would use the full main disk, right, rather than the partitions?
It might, it will definitely create problems. From my experience, this is the best way to do it. But you would still need to run the VG create. You won't be able to do PV create or VG create. Like for example, if you do VG create and then you go ZMPT02 dev SD SD E1. Okay, so it says volume group successfully created. You do VGS, and if you do PVS, and it is showing here, right? Where is it go?
Yes, it's on the bottom.
Yeah, it's gonna do this here, but later on when we're gonna mount it, it will give you a problem.
Okay.
So I wouldn't recommend that. I would recommend going through the PV create.
Okay. So just follow the whole process then.
Yeah, follow the whole process, because somewhere down the line you will get stuck. Once the volume is mounted and started using by the application team, it's going to be very difficult. It's going to be very difficult for you to undo what you have done.
Okay, because I'm getting a little bit confused. Not really confused, but since we used the partition rather than the main disk itself, if in a partition we had used less space, let's say instead of the full disk space 4G we use 2G, and then for SDC we use 6G rather than 8G, then the main disk would still have some space left in it for us to use later on. But since we use the full space now, the main drives are they useless, or can somebody still use them?
No, the main drives, you're referring to the
main the main hub, like the SDB and the SDC, rather than the partitions. Because we created the partitions with the same space that the drive has.
Yeah. So I mean, this is jumping the gun here, but there is one more place you have to go is say this /dev/mapper, and if you do ls-l here, it will create a symlink over here. When we create the partition type, it will create the symlink here, and this is what we needed to do the mapping to the mount point.
Okay.
So that thing is coming up here. Let's go through this process first, and then you could experiment around. Definitely, you could definitely experiment around, because what you have is you have another 2 servers. You could play around in there, and then you could delete them as many times, and then do this here. But let's follow the process here, because there are many ways to doing same thing in any environment. But this one I've been following for years now, and it's been working very well.
Okay, that's fine. Thank you.
Yeah, very good question. Okay, so we did this PV create. Let me get back here. So now what we have is we are dealing with these 3 drives here. So volume group is 1, 2, 3. Okay, this is PVS. And if you do VGS, we have one volume group here. It's a 28 GB. And it has 3 disks, and the 28 GB is considered as a single disk. Okay. Now what we're gonna do is we could create the partition on the volume group ZMPT01. What time is it now? You know, I should stop here because the next
2
topic
o'clock.
is gonna continue on. Yeah. All right, let me stop it here and then pick it up where we left off here from here tomorrow, and then we'll go from there. Any questions? Put in a chat and I will answer it.
Brother, it was really okay. Go ahead.
Yeah, go ahead.
It was really hard for me to understand today all these. So if you can upload, I'll go over it and then try to practice more.
You're breaking in and out. What are you saying?